Hello, my dear students. I am Dr. Vikas Kamra. I welcome you all on my YouTube channel, Dr. Vikas Kamra. This is the next video in our data structure important question series. The very first four videos which I recorded were on numericals on two-dimensional array and three-dimensional array, as well as the operations of stack, for example, infix to postfix conversion and evaluation of postfix expression. So this is the next topic, queue data structure, which we are starting today. In this topic, we'll study three type of queues, the linear queue, the circular queue, and double-ended queue, which is also called as DQ. So we'll discuss the theory part, we'll discuss the example diagrams, as well as the algorithms for linear, circular, as well as double-ended queue. So we are starting this video. So till now, if you have not subscribed to my YouTube channel, please subscribe to my YouTube channel where you will get different playlists for your career guidance, research paper publication, projects, and as well as the important topics. A special playlist is for podcast. So I do podcast with my ex students, those who are working in good IT companies. So you can also watch their podcast for your career guidance and placement. So let us start with the queue data structure today. As you know, queue is very important data structure. So queue data structure is basically a kind of a linear data structure. Linear data structure means where the items enters in the array in a linear fashion, as well as when they are deleted from the array, that is also a linear fashion. Linear means one after another. Queue is a kind of a data structure with first in first out principle. Means if the item or element which is inserted first in the queue will be removed first. As we know, stack is last in first out, but queue works on first in first out principle. So I am explaining the diagram and definition to you as well. So first start with the definition. It is an abstract data type in which elements are inserted, which is called as NQ operation from one end. That end is popularly known as your rear end. So this is your rear end, or sometime it is called as the tail end. And the items are removed from the another end, that is also open end, which is called as front end or sometime called as head. So as stack is only one end open data structure, queue is both end open data structure. So now we'll discuss different type of operations which we can perform on queue. I will also show you the diagrams as well as the algorithms in this video. So very first operation, as I already told you, NQ operation. So the NQ operation is used to enter the element or insert the element in the queue from the rear end. But DQ operation is used to remove the element from the front end. So insertion takes place at rear end, deletion takes place at front end. Similarly, peek is the operation which is performed at the front end. It is used to view the element or the print the element without removing it. Means you just want to print the element but do not want to remove them. So then in that case, peek operation is used. Is empty is a kind of an operation which checks whether the queue is empty or not. Say if we want to delete something from the queue, then we need to use this operation. Similarly, is full is used to check whether the queue is full or not. It is checked when the insert operation is performed in the queue. So these are the five basic operations. Today we'll discuss their algorithms as well. But from starting, I am just first explaining to you the types of queue which we can have. So there are different type of queues. Say simple queue, that is called as linear queue. It works on the basic first in first out principle. Then circular queue. Here the front end and rear end are connected with each other. It is in the form of circle, but linear queue is in this fashion. So linear queue is like, so when you say about linear queue, so this is one dimensional array. If you can see from here, the items are inserted. From here, the items are deleted. But here in this circular queue, a complete queue is there. So you can connect the front end and rear end together. I will show you the next page with the clear diagrams. So now third one is the priority queue. It is mainly used when elements are deleted from the queue based on their priority. It does not follow always FIFO order. It works on the priority number. So a priority number is assigned and it works on the priority of the element which is to be deleted. Generally, the system commands have high priority as well as the user commands have low priority. The most important one is double-ended queue. So double-ended queue, also called as DQ, where insertion and deletion takes place at both ends. This is important question because here we have to do four algorithms: insertion at beginning, insertion at end, deletion from beginning, deletion from end. So let us first start with the diagram. As you can see here, this is a linear queue, or simply it is a queue. Here the items are inserted from this end, that is called as our you can say rear end. So from this end items are inserted, and from this end, from this side, items are deleted. So first item will come here, second item will come here, third item will come here, and fourth item will come here. So it is the diagram of linear queue. There are some disadvantages with linear queue that I will explain in circular queue. You can see now here circular queue is here. So in circular queue you can see a kind of a circle is formed. So this is the circle. In this circular queue, items inserts from the rear end only, deleted from the front end, but the front end is connected with the rear end. So as you can observe that once the linear queue is full, so we cannot insert more items in the linear queue if it is already full. But if the rear end is not empty, all other elements are removed. The circular queue helps you to insert the element, but linear queue do not help you to insert the element. So circular queue overcomes the disadvantage of linear queue. Now you can see double-ended queue. This is very important queue because here NQ and DQ both can takes place from both end. So double-ended queue, NQ can be done here as well, or NQ operation can be done from this side as well. DQ generally takes from front end, means deletion from front, but DQ can also be done from this end. So double-ended queue has the insertion and deletion operation possible at the both ends. So let us start the working and application I will explain you in the last. There are different applications of queue. Let us start with the algorithms. This is main important part. So algorithms of queue data structure. First I will start with the linear queue algorithm. Linear means simple. So very first step which we need to perform is the initialization. Means you have to start the queue because if this kind of one dimensional array is made, so this is linear queue. Initially the front value and rear value both are set to -1, means they are not positioning to any particular location. This is 0 index, this is 1 index, this is second index. So different type of index values are there. So in that case, front and rear are set to -1, means they are not pointing to any location. When we go for insert operation, then you can see the algorithm for insert is this one. This is the simplest algo. As I already told you, when we are inserting something, we need to check the queue overflow condition, and this is the linear queue overflow condition. You need to remember this one. If rear is equal to max -1, because the array index starts from 0, so max -1 is the last location. If rear is already pointing to max -1 location, in that means the queue is already full. So we simply return from here. We do not push, oh sorry, not push, we do not enqueue the item in the queue. But if front is -1, second case means there is no element, it is the empty case. The second case represents that the queue is empty. First case represents the queue is full, so queue overflow and return. But the second case, if queue is totally empty, In that case, we need to set to front is equal to 0. Means the first element is inserted in the queue. So here, if the queue is empty, we simply set front is equal to 0. Or third case, neither the queue is full nor it is empty. So we simply need to increment the rear pointer by 1, and at queue rear we need to insert the item. So total we have checked the four cases here. Very first case is your, you can see here, this is the first case which shows queue is full. Second case which shows queue is empty. If both cases are not true, then we simply increment rear by 1, and in that rear we insert the item. So it is a very simple algorithm. Now if I'll talk about the deletion algorithm, so this is the algorithm for deletion from a queue. As like we check the overflow condition in NQ, so we check underflow condition in DQ. So you need to remember this is the condition for Q underflow. If front is already equal to -1, means there is no element in the queue, or front is greater than rear. Both cases you need to check that queue is underflow. So we cannot delete an item from the queue. You simply return from here itself. If this condition is false, then this is the main part. The item which is stored at queue front, we will put it in item. So the value at queue front is stored in item, and then front is incremented by 1. So first you need to store the value which is at the front location of the queue into the item. Then you increment front by 1. So in that way your one item will be deleted. But fourth case is that if front is greater than rear, we also need to check this condition. If front is greater than rear, it means there is only one element in the queue. Once you delete that element, you simply has to set front and rear both equal to -1. Means after deleting of this one element, queue became empty. So both the cases are checked here, whether already the queue is empty or there is only one element in the queue or more than one element in the queue. In all the cases, different operations we need to perform. So now coming to our next kind of algorithm in queue, that is circular queue. So this is the circular queue algorithm. As we know, a circular queue connects the end of the queue with the front, means rear and front end are connected with each other. So making use of all array slots efficiently. So this is the, you can say, modulo algorithm or modulo arithmetic formula which is to be used in circular queue. Rear plus 1 modulus max. Modulus means remainder and max is the size of queue. So you can just, with the help of this particular equation, we do the queue insertion in the circular queue. So very first you need to initialize the queue. As you can see here, initialization means setting the front and rear is equal to -1. So you can see here the portion which I have highlighted, front and rear both are set to -1. Now coming to insert part. So queue insertion algorithm is very important. If we'll talk about circular queue, it is a four-step process. So very first step is you need to check whether queue is already full. So this is the condition for queue overflow in circular queue, especially for circular queue. If front is equal to rear plus 1 mod max, you need to remember this particular condition. If front is equal to rear plus 1 mod max, then you need to print queue overflow and return. If front is already equal to -1, this case, it means the queue is already empty. Simply set front is equal to 0, means one element is inserted. If both the cases are false, then rear is equal to rear plus 1 mod max. This mod max is actually for circular queue. If it was a linear queue, then only rear is equal to rear plus 1 was there. But if it is a circular queue, you need to find the modulus max. Max is the size of array. And once the rear is incremented, you should add the item at the queue rear. So this is the algorithm for circular queue. Now coming to our next part, that is deletion algorithm from circular queue. This algorithm is very important. As you know, in deletion you need to check the queue underflow condition. So this is queue underflow. Here if front is equal to -1, means there is no element in the queue, queue underflow goes there. If item is there, then this second step helps you to store the value at q front in the item. This item will be printed as an output. So once we taken the item, then the third case in circular queue, you need to remember, if front is equal to rear, means both are pointing to the same location. It means there is only one element in the queue. So once we deleted that element, you need to set front is equal to -1 and rear is equal to -1. It means there was only one element in the queue, and after deletion of that element, both front and rear came to -1. If this case is not true, means the queue is neither empty nor there is one element. There are more than one elements in the queue. Then this line will be used to increment the front pointer. Front is equal to front plus 1 mode max. As I already told you, in circular queue, mode max is required. So, if it was a linear queue, then front is equal to front 1 was sufficient. But here, mode max you need to done. So, very simple algorithm like your, you can say linear queue and circular queue. Now, coming to the next part, that is our double-ended queue. Double-ended queue has four algorithms. In the double-ended queue, where insertion and deletion takes place at both ends, that is front and rear. At both ends, the operations can take place, but there are two variations in it. You can make input restricted if you want to insert at one end, or output restricted if you want to delete from one end only. So input restricted and output restricted. There are two cases. So we'll cover all four cases here. First, you need to initialize the queue, which means you need to set front and rear is equal to -1. So now coming to the very first algo, that is our for insertion at rear. This algo is same as it is same which you did in the circular queue. So as you know, front is equal to rear plus 1 mode max, you need to check this condition, then it is the overflow. Just you need to remember this condition. This is the overflow condition in DQ. If front is equal to rear plus 1 mode max, then you simply print DQ overflow and insertion cannot take place. If front is -1, it means the second case the queue is already empty. You need to set front and rear both equal to 0. If it case is not there, means queue is not full, not empty. Then you need to set the rear is equal to rear plus 1 mode max as like in circular queue, and then you should insert the item at queue rear. So this is the case for insertion at rear end. So now coming to the insertion at front end. So this is the algorithm for insertion at front end. Again, this is the new case because generally we delete the element from front, but here we insert the element at front. So you need to listen this algorithm carefully. So the condition is same. If overflow condition, I need to check if front is equal to rear plus 1, then overflow. And second case, if queue is already empty, then front is equal to -1 is there, then you need to set front and rear equal to 0. Now this elif and else case, you need to remember this for DQ. If front is equal to 0, in that case you need to set front is equal to max -1. Otherwise front is equal to front -1, not plus 1. So here for insertion from front end, you need to do front is equal to front -1. You need to remember this case, front is equal to front -1. So in that case, at that front location, you should insert the item. So this is the main logic for insertion from front end. So it was not possible in linear queue and circular queue. Now coming to the deletion part, deletion from front is very similar as we did in the circular queue. First we need to check the underflow condition. If front is equal to -1, then DQ underflow. If not there, store the item which is available at queue front into the variable item. After that, you need to check if front is equal to rear, means there is only one element in the queue. Then you set front and rear both equal to -1. Otherwise, simply front is equal to front plus 1 mode max. It is same as in the circular queue. Now the unique and the different part is DQ from rear. Generally, we do deletion from front, but here we are deleting from rear. So you need to remember this algo carefully. There are four steps in it. Very first step, you need to check whether front is equal to -1, then it is underflow condition. So you cannot delete the item. Otherwise, second step, the item which is available at Q rear, you have to store in the item variable. So these two first steps are similar. If the queue is empty, print underflow and exit. Otherwise, the item at queue rear should be stored in the variable item. Now, step number 3 is the main logic for your DQ. If front is equal to rear, again same case, there is only one item, then you simply set front is equal to 1 and rear is equal to -1. Else, if rear is equal to 0, now this is rear is equal to max plus 1. You need to perform this operation. It represents the operation for your deletion from rear end. So this is the main part. I am highlighting it once again. If rear is equal to 0, you need to set rear is equal to max -1, else rear is equal to rear -1. This is the logic for this special case that is being used in the you can say deletion from the rear end, and at last return the item. So these are four logics which I have explained you in the DQ. If a question comes in exam for DQ, you need to write these four algorithm. If a question comes for circular queue, then this is the circular queue algorithm. You need to write these two algorithm. If a question comes for linear queue, then you need to write an algorithm for linear queue. Now the last one is the applications of queue. There are so many real-time applications of queue data structure. Very first is the CPU scheduling. You can study all the chapters of CPU or operating system or process scheduling in your operating system subject in the next semester. But you need to remember the application of queue is the CPU scheduling, print spooling. Say you have given some print command on a print server, then the spooling operation can be performed with the help of a queue, means first in, first out. Breadth first search. When you will study the graph or tree chapter, then breadth first search can be performed by queue data structure. Depth first search is used for stack data structure, but we are talking about queue, so BFS is used. Then handling request in web server. Say you are contacting Facebook, Instagram, or any other application from client location. Then different servers are interacting with the clients. So managing these web server requests can be done with the help of queue data structure. So handling web server, data buffering, like input, you are pressing any key from keyboard or clicking the mouse, so input output operation or other kind of operation where data is transferred, it can be done with the help of queue data structure. Then call center system or ticket booking, like operating system performs some system operations, user is sending some commands, so tickets are generated and they are handled in queue data structure in real time as well. So you are calling to a call center of any particular company or online ticket booking. Their queue data structure application is used. Simulation of real world queues like supermarket, you are going to purchase something, traffic signal system. So first in, first out queue is used in all these applications. So these are the real time applications of queue. So today we covered three types of queue: linear queue, circular queue, as well as double-ended queue. So in your exam, generally circular queue or double-ended queue example comes. So you need to write their algorithm, their definitions, as well as their diagram. So if you have any doubt in this video, you can write in the comment section of this video. I will answer your queries. So I hope you understand today's topic. So thank you very much. You can stay connected with my YouTube channel for more videos. So thank you, students.